everybody, my name is Miss Sarah and I'm so excited that you are all joining me for this month's episode of STEAM Club. And this month we are doing a special NASA at My Library edition of STEAM Club. And if you're not familiar with it, NASA at My Library is a great program that we are a part of here at Lee County Libraries that helps us bring you programming related to NASA. So in this month's video, we are going to be talking about Ingenuity, which is the Mars helicopter, and making our own version of a Mars helicopter out of some paper. So let's start off by talking about the different rovers that NASA has put onto Mars. Now you might be asking, what is a rover? So a rover is a vehicle that we put on another planet to do experiments. And these vehicles are not piloted by a person in person, so it's not like a car you drive where you have to be in the car driving the car. It's more like a remote controlled vehicle, but the remote controls are operated here on Earth where the rovers are on Mars. And so the scientists at NASA have to do a lot of experimenting to get these ready to be flown to Mars and then ready to do experiments while they're there. So these are just a couple of the NASA rovers. And these are Curiosity and Perseverance. And both of these rovers are currently doing experiments on Mars. Curiosity has been on Mars since 2012, and Perseverance just landed on Mars in February of 2021. And they're on different parts of Mars doing research and doing things such as taking samples of the soil and taking pictures for scientists to study. And they get us a lot of really useful information. But of course, there are limits on where these rovers can go because they have wheels and they can only operate on certain types of terrain. And so having something like a helicopter on Mars would be of great help to study areas like the mountains and deep craters that these rovers can't get into safely. And that's where Ingenuity comes into play. So this is a picture of Ingenuity, the first ever helicopter on Mars. And Ingenuity came to Mars at the same time as the Perseverance rover, so it landed in February of 2021, and it's currently fully operational. And this is a clip of the Ingenuity helicopter in action. You can see that it is currently on Mars in this video, and it is able to lift off and fly for up to 90 seconds and then land safely back down. Now, the main point of sending the Ingenuity to Mars was simply to prove that it is possible to pilot a helicopter on Mars. But we've also gotten some great images and videos sent back to us from the Ingenuity. So in this next slide, I'm going to show you some clips that were taken from the camera that is on the bottom of the Ingenuity helicopter. And so these are pictures of the ground that it takes as it lifts off. And in this video, you can see that the shadow of the Ingenuity helicopter is changing size and getting smaller as the helicopter lifts up off the ground. So how do helicopters work anyway? Well, helicopters work by having angled blades on the top of them that spin around really fast. And the way that these blades are angled has the wind come up on top of them, which creates lift. And as the blades spin around, it pushes the air down. And as we talked about, if you watched our balloon rocket launch video, when you create a force, there is an equal and opposite reaction. And in this case, the reaction is that as we create force of the air going down, well, the ground isn't going to move, that ground is solid. And so instead of pushing the ground down, it pushes our helicopter up. Because as the air comes down, it can't go down any further, that causes our helicopter to move up. So let's make a paper version of a helicopter to get a better sense of how helicopters work. if you're going to follow along with this experiment at home, these are the supplies that you're going to need. First of all, you're going to need a copy of the template for the paper helicopter. And you can find this at jpl.nasa.gov/edu or by following the link to it that I have included in the description of this video. If you don't have access to a printer, you can also trace out this design on a piece of paper and do it that way. In addition, you're going to need a pair of scissors to cut out your templates. And then in order to experiment with these helicopters, we are going to use a tape measure and a stopwatch. And if you don't have a stopwatch like this, you can always use one on a cell phone or another electronic device. The first step in this experiment is to assemble our paper helicopter. And in order to do that, we're going to start out by cutting along these dotted lines with our scissors. And make sure you do these little indents here as well and cut down in between A and B. Now that we've cut along all of our dotted lines, we are going to fold on these solid lines. So first of all, X and Y will get folded in towards the center. So I'm going to flip it over and then fold these in along those black lines. And then Z will also get folded up and in towards that center. So we'll fold it up here on the back. And then A and B are going to be folded in an opposite direction from each other. And make sure if you see this line is a bit slanted, we want to follow that slant with our folds to get the right angle for these. Because remember, we need the blades to be angled in order for them to be able to create lift. So I folded B backwards, and I'm going to fold A towards me. And this is what my finished helicopter looks like. Alright, so now that we have our paper helicopter assembled, let's drop it and see how it works. You might have noticed that while our paper helicopter doesn't have an engine like a regular helicopter or the Mars helicopter, it still spins because the blades are catching the air as it drops and pushing against it. And in order to show how this is able to catch the air, I'm going to compare what happens when I drop this versus when I take one of the unfolded templates and drop that. And let's see if there's any difference in how they fall. So I'm going to hold them up at the same height and we'll see what it looks like when I drop them. So you might have noticed that this one stayed in the air a lot longer, and that is because, like I mentioned, these blades are catching the air as it falls. Now, the scientists at NASA had to do a lot of experimenting to figure out how to get a helicopter to work on Mars. And that is because the air on Mars is much thinner than the air here on Earth. And so the regular amount of lift that it takes for a helicopter to launch needed to be more on Mars in order to keep this in the air, because there's less air for the blades to push against. So NASA did a lot of experiments to figure out how to make this work. And let's do for some of our own experiments to figure out what things would make a helicopter fly better. And if you're following along with this at home, this is the step where your tape measure and your stopwatch are going to come in handy. So in order to make sure our experiments stay the same each time, and that the difference is only to do with the helicopter and not something else, we need to keep everything else in the experiment the same. And in order to do that, in this, we're going to make sure that every time we drop the helicopter, it's from the same height. And then, if you want to time how long it takes each helicopter to design to fall, you can use your stopwatch to time how long it's in the air for. You might need someone else to help you, either to measure or to take the time, because your hands are going to be busy dropping your helicopter. So if you have a friend nearby or a grown-up, this would be a great time to ask them to help you out with your experiment. And you can change your helicopter in any way you want to see what sort of difference it makes. Here are some of the differences that I'm going to be testing out. So in this hand, in my right hand, I have my regular helicopter that I was just dropping. And in my left hand, I have a helicopter that I made out of cardstock. And cardstock is a thicker, heavier sort of paper. So this paper weighs more than this paper. And in addition, I've added some paper clips. So this one is even heavier than this one. So let's drop both of these from the same height and see which one falls faster. Let's drop them again to make sure that you're really getting a good view. Alright, so you probably saw that this one, the heavier one, landed faster, which means our lighter helicopter stayed in the air longer. And that's actually one of the things that NASA made sure to do with their helicopter. The Ingenuity helicopter is super lightweight because the lighter the helicopter, the longer it can stay in the air and the less lift it requires to take off. Another thing that I think might affect how long my helicopter is able to stay in the air is how long the wings are. So my hypothesis, which is a guess that you make and then test out in a science experiment, is that having longer wings will help my helicopter stay in the air longer. So on this side, again on the right side, I have my regular helicopter. And then on the left side, I'm going to make some changes. So I have another helicopter folded up, and these are the same weight this time. But this time, I am going to cut off about 1 inch of these wings and see if that makes a difference on how long my helicopters are able to stay up in the air. So let's drop these and see. Alright, so I'm going to drop these from the same height, and on the right we have the one with the regular length wings, and on the left we have the one with the short wings. So let's drop these and see which one stays up for longer. I think that was pretty close. Let's look at it again. Alright, so my hypothesis was actually correct. You probably noticed that the one with shorter wings did in fact fall faster. So this one with the regular length wings was able to stay up even longer. I wonder what would happen if someone made an even longer version of these by tracing this template, but making A and B even longer. Well, that's something that you could try out at home to figure out how to make your helicopter stay up in the air even longer. There are lots of different things that you can try. And in doing so, you will be acting just like the scientists who helped send the Ingenuity rover into space by experimenting with your designs and perfecting them to make them even better and better. And those are all of the experiments that I have planned for today. I hope that you enjoyed learning a little bit about how helicopters work, and I hope that you will try out this experiment at home and find out even more ways to keep your paper helicopter in the sky even longer. Thank you all so much for watching!